All right, everybody, now that we have collected some data, we are going to have to do some organizing of the data so we can analyze the data better. So the first thing that we can do a lot of times is do some statistical analysis on our data. And one of the calculations that we do very often in science are making averages, right? Averages. So when you kind of think of averages, we're kind of looking for that middle number. You can kind of think of it that way. So we're kind of looking for what's going to be in the middle, right? Because we know there can be some variation, especially when we're outside with air temperature. We know that air is not going to be have an even temperature throughout. So when we do look at averages, what we do is we are going to take the total of our data. So the total, the sum, that means we add it together. And we're going to divide it by how many numbers we added together. So how many numbers added together. Okay, and again, this right here, this bar here in the middle means divide. And if you look at it, it actually, that fraction bar is a divide symbol. We got a number here, and a bar here. Let's say, for example, you wanted to take the average ages of some students' classes and students in the classroom. Okay, so you collect some data. So let's say some students are 14, we have 14, 13, maybe a 15, and a 13-year-old student. So how we would get that average is we'd add all of these together, okay, to get that total, the sum. So we have 14 plus 14 plus 13 plus 15 plus 13. All right, that is going to be 69, okay, and we know that the students in the classroom aren't 69 years old. So now we're going to divide by the number of students right here. 1, 2, 3, 4, 5. There's 5 ages. Divide by 5. That's going to give me, so I'm dividing that by 5, and that gives me an age of 13.8. Now in this case here, I didn't measure their ages to a decimal. So I really don't know if it's 0.8 or not. So what we do, since this is 5 or higher, we're actually going to round that up. And the average age of the students would be 14 years old. To double check my answer, again, we said averages are middle. So I make sure that this answer is somewhere in the middle. So it has to be in between my lowest age, which is 13, and my highest age, which is 15. So that way I can double check my work to make sure that I've calculated it correctly. So if we look at the greenhouse data to take the average, what you'll be doing is you're going to add all these together, all right, and then divide by the total numbers that you added to get your class average. So for here, notice that group 10 is missing. So when you add all of these together, okay, you're not going to divide by 12, you're actually going to divide by 11. All right, because you only have 11 temperatures, all right? And then you would do the same over here. So you add them all together, and then you would divide by the number of temperatures, which is 11, which is going to give you your class averages. Once you've figured out your class average, all right, then we're going to do a calculated data table for all the 9th grade or science classes that are collecting data. So that would mean whatever your average is here. So this is our outdoor temperature, right, in pink. All right, this is first hour, the time's 8:50. And here I have first hour down here, and then you would put the time, 8:50, because that's when it was collected. And then you would record that outdoor temperature there. So again, outside. Now we have our greenhouse data here. Oh, that time was also, we're going to say 8:50 a.m. All right, so whatever you calculate here, you are going to put here. All right, and then that time is going to be 8:50 a.m. in the morning, right? Then you'll get this other data here, and then you are going to be graphing this data right here. So kind of a quick graphing review. All right, this is right here an XY chart. All right, so our X, right, is, let me grab another color. Our X would be right here. All right, the time, so that is going to go on our X. It's also what we call our independent variable. So I'm just going to put IV here. That might make more sense a little later. So that's my X. All right, and now here we have actually two Y's. So we have a Y here. So that's going to be one line on your graph. And then we have the greenhouse data here, which is going to be another Y on your graph. And this is going to be a line graph because you're going to have times right here on your X. All right. And since time is in order, all right, by numbers, we can actually go ahead and do a line graph for that. So if we look at, all right here, a simple graph, what we have is the X. The X is your flat axis. So X is flat. That's here. Okay. So these numbers here are going to get plotted along this axis here. And then here is your Y, your up and down. So this is your Y axis. Okay, and these are the temperatures right here. This is your Y that are going to be plotted on this axis here. Okay, so if we look at the graph you have on the next page, all right, we can actually, sometimes it's easier to just kind of rip them so you have them. So we have our title, all right, so you're going to come up with a title that describes what you're going to have on your graph. This is your X, all right, so whatever your X is, because this is what we're graphing here, this calculated data, okay, that X again goes here, so this is again your X axis, all right, so you're going to have time. And the earliest time we have is 8:50. You don't have to start like at midnight or anything. So you can have here, okay, again, time. All right. So we have time, okay, in units. This is, I don't know, hours, minutes. But we can even put maybe 8 a.m. And then you figure out, I mean, we go all the way until like 3 o'clock. All right, and you want to fit all that data in a little extra, right, maybe on the end here, and they should all be kind of evenly spaced apart, okay? So it'd be like 8, maybe every half an hour, however you want to do it, 8:30, 9, 9:30, 10, 10:30, 11, 11:30, noon, 12:30, 1, 1:30, 2, 2:30, 3, something like that would probably work out. So like every half an hour. All right. Then you have your Y axis here. All right. That's your Y. So your Y is up and down here. And again, you want to label that axis so we know what's up here. So if you look here, it says temperature in degrees Celsius. You want to make sure that you have that unit. So you can go ahead and write temperature. All right, temperature, and then in parentheses you have degrees Celsius because that's what we measured it in. And again, you don't have to start at 0, okay, because 0 degrees Celsius is freezing and we didn't have freezing. All right, so what I like to do is I like to look at my lowest temperature and start a little before that. So my lowest temperature here is 10. So I might start at 10 degrees right here. And then I try to make it so it goes up. And again, it should be even. So if you're going to go by 2s, it should be 10, 12. No, I think 2 would be too much. So maybe even a half a degree or maybe 1 degree. So it'd be like 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I don't know if that'll be high enough. So maybe half degrees. All right, count it out. All right, so you're going to be making 2 lines. All right, on this graph, 1 is going to be your outside temperature, and then 1 is going to be your greenhouse temperature. Okay, you can make your lines whichever color you want. So again, your points, let's say 850 would be about right here. And if we calculated it to about 13 degrees, let me see, 10, 11, 12, and you don't have to number all of them. Then I would make dot here, right? And then I make a line for my outside temperatures, connect them, and then use your key. Be like outside. Right, and then make a line for your inside temperatures with a different color. And I always like green because it's a greenhouse, makes sense. Right. And do that there. All right, so also what you can work on too is, if you haven't already, is your systems diagram. So if you get done with graphing your information, you can make that diagram of the system by identifying the boundary, components, and interactions of the greenhouse and making your drawing right in here. All right, making your diagram. All right, good luck.